Hi class, in this video we're going to talk about how to take the square root of a perfect square that are fractions. So before we do that, we have to be able to identify which rational numbers are perfect squares when they're in fraction form. So the first step, if your answer is in a decimal form, you want to first convert it to a fraction. And if you can't convert your decimal to a fraction, then it's not possible to have a perfect square, right? So you need it to be in a fraction form. Once it's in a fraction form, you want to simplify the fraction to its lowest terms. And then you want to take the square root of the numerator and the denominator separately. And if numbers on the numerator and denominator are still whole numbers, then the fraction is a perfect square. So for example 1 here, I have 49 over 121. I don't believe I can reduce these any further to the lowest terms. I'm simply going to take the square root of the numerator, and then I'm going to take the square root of the denominator. So in this case, the square root of 49 is going to be 7, and the square root of 121 is going to be 11. Since my answer is 7 over 11, which are both whole numbers on the top and bottom, I would say for 49 over 121, yes, this number is a perfect square. And now for example 2, I have 2 over 9. So in this case, I'm going to do the same thing. I'm going to take the square root of the numerator and then take the square root of the denominator. So the square root of 9 is simply going to be 3. But, however, the square root of 2 is going to be 1.41 dot dot dot, meaning it's going to be 1.41 and it's going to continue on forever. So since the top number is not a whole number, I basically just say no, not a perfect square. Because to be a perfect square, once I get into a fraction form and I take the square root of both the top and bottom, they both have to be whole numbers. And since the top number here is not a whole number, this is not a perfect square. Okay, let's try a couple more examples. Here I have 0.1. Now, first things first, we want to change this to a fraction. Since this is 0.1, that's 1 is in the tens place. I know this is going to be over 10. 1 is here. All right, 1 down, 1 over 10. So 1 over 10, is that a perfect square? Well, let's try to take the square root of 1 and then take the square root of 10. Now, if I take the square root of 1, I'm simply going to get 1. But if I take the square root of 10, I am not getting a nice number, right? I'm getting probably 3 point question mark, question mark, question mark, dot, dot, dot. I don't know what that's going to be. So I'm going to say no, not a perfect square. Okay, example 4, 0.16. Since the 1 is the tens place, the 6 is the hundreds place, I know this is going to be out of 100. And I'm simply going to write 1/6 on the top. So this is 16 over 100. Now in this case, I could technically reduce this. If I take the square root here already, the square root of 16 is 4, and the square root of 10 is, sorry, and the square root of 100 is 10. So I'm going to get 4 over 10 if I take the square root here. But let's just simplify it because, our rules are to simplify this. So I can most likely divide the top and bottom numbers by 4. In this case, 16 divided by 4 is going to be 4, and 100 divided by 4 is going to be 25. So in this case, now let's take the square root of the top and bottom number. So I got the square root of 4, and I got the square root of 25. The square root of 4 is simply going to be 2, and the square root of 25 is simply going to be 5. So I got 2 over 5. Since both top and bottom are whole numbers, I'm going to say yes. This is a perfect square. Okay, now let's move on to example 5 and example 6 here. So for example 5, I got 1.2. Since my number for the 2 is in the tens place, this is going to be out of 10. And then I simply write what I see there without the decimal. 1 and 2 without the decimal, 12 over 10. And if I reduce this by dividing top and bottom by 2, I'm simply going to get 6 over 5. Now you probably already noticed, but if you take the square root of 6 and the square root of 5. They're both not going to be very nice numbers because these are not, perfect squares. Like the square root of 6 is not a perfect square. The square root of 5, 6 is not a perfect square. 5 is not a perfect square. So if you take the square root of 6 and the square root of 5, you're going to get some really rough numbers. So I'm just going to say no. Not a perfect square. Now for example 6, since my 5 is in the hundreds place, this can be over 100. And I'm simply going to write the top number without the decimal. So 225 over 100. Now in this case, if you were to reduce this all the way down, you can see that it would equal, well, I guess I might as well show you the math for it. If I divide the top and bottom number by 25, the top number will now be 9, and the bottom number will now be 4. So if I take the square root of 9, and then I take the square root of 4, I'm simply going to get 3 over 2. Since the top and bottom are whole numbers, I'm going to say yes. This is going to be a perfect square. But notice if I decide to take the square root right here from 225 over 100, the square root of 225 is going to be 15, and the square root of 100 is going to be 10. So it would have showed that it was a perfect square anyways, but for consistency, you want to reduce anyways to its lowest terms and then check. Okay, now we move on to the original objective of this video, which is to take the square root of perfect squares that are fractions. So in our first example, we have the square root of 64 over 100. So just like before, I can simply split the top number and the bottom number and take the square root of them separately. So in this case, I have the square root of 64 over the square root of 100, and the square root of 64 is going to be 8, and the square root of 100 is going to be 10. So that means that the square root of 64 over 100 is 8 over 10, or you can say this is 4 over 5, or you can say this is 0.8, however you want to say it. Now for example 2, I have the square root of 18 over 50. Now in this case, if I were to take the square root of 18, you can already tell that's not going to be a perfect square. Neither is the square root of 50. So I feel like we're missing a step. And the step we're missing is, remember, we should reduce this to its lowest terms as soon as possible, right? So in this case, I have the square root of 18 over 50, but I can reduce this by dividing the top and bottom numbers by 2, right? And upon doing so, look what happens. I'm now going to get the square root of, now 18 divided by 2 is going to be 9, and 50 divided by 2 is 25. So now I have the square root of 9 over 25. So now if I split it into the square root of 9 on the top and the square root of 25 on the bottom, the square root of 9 is going to be 3, and the square root of 25 is going to be 5. So that means that the square root of 18 over 50 is simply going to be 3 over 5, or 0.6. Okay, now I want to go over an example where we have the square root of a decimal number. So our first step should be to express this decimal number as a fraction. Now, 8 is in the tens place, and 1 is in the hundreds place. So because 1 is in the hundreds place, and it's my last number on the right-hand side, I know this is going to be over 100. Now I simply just place the top number right on the numerator while ignoring the decimal. So I would write 081 or simply just 81, because 081 is the same as 81. So in this case, I know I can express this square root now as the square root of 81 over 100. Now we simply do our trick here. We simply split up the top number and take the square root of it, and then take the square root of the bottom number. So in this case, the square root of 81 is simply going to be 9, and the square root of 100 is going to be 10. So I get 9 over 10, or 0.9. And just to check your work, if you guys don't believe me, go take out your calculator, type in the square root of 0.81, and see if you get 0.9.